Okay, so problem number 16 asks us to draw a two-circle Venn diagram and shade the region. All right, here's S, here's T, and we want to shade the region S prime intersect T prime. And the way I'm going to read it is like this. This means everything outside of S, as well as everything else outside of T. So I want things that are outside of S and outside of T. And one way to go about this is, maybe you can just see it, but if you don't just see it, what you can do is do it by pointing. So this is an and, so I need two yeses. So what about right here? Is that outside of S? Yes. And is it outside of T? Yes, this point here is outside of S and outside of T. So I'll just put a dot there to remind me to shade that. Then what about this point here? Is that outside of S? No. Now this is an and, so I need a yes and a yes. I got a no, so we can keep going. What about this point? Is that outside of S? No. So keep going. Is this outside of S? Yes. That's outside of S. And is it outside of T? No. So the only point that's outside of S and T is this one right here. So I'm going to do the best I can to shade that region. So the region that I'm shading is all of this here. Any point out here is outside of S and outside of T. Now, in problem number 18, we're asked to shade the region corresponding to this set. So what I want here is everything that's outside of S, as well as, along with everything that's outside of T. Let's do this by pointing. So now this is a union, right? So I just need at least one yes when I do it by pointing. So what about out here? Is that point outside of S? Yes. Happens to also be outside of T, but I have at least one yes. So you know what I'm going to do here is I'm going to put a dot here just to remind myself to shade that region. Then what about here? Is this point outside of S? No. Is it outside of T? Yes. Now remember, it's an or, so I just need this one or this one to be true. This one is not true. It's not outside of S, but this one is true. It is outside of T. So let's put a point there. Remind us to shade that region. And then what about this region right in here? Is it outside of S? No. Is it outside of T? No. So nothing in here works. I don't get any S's here. So any point here is not outside of S and not outside of T. So that doesn't work. Let's move over here. What about this? Is this outside of the S? S? Yes, it is. It happens to be in T. This is not satisfied, but this is. It's outside of S. So let's put a point to remind us to shade. Okay, so I've done as best I could here. So any point in this shaded region is outside of S and outside of T. So the only thing that doesn't work here is this right here. You know, in fact, let's look at this one just a little bit more. Let's look at this region right here. Well, let's do it in black here. Let's look at this region right here. Where is that? That region is just the opposite of this. This is inside of S. Here's where we are. We're inside of S, and we're inside of T. So being inside of S and inside of T is exactly the opposite, right? You can see it's the opposite of this region, which is here. So this set here is the opposite of this set here. In other words, this is equal to S prime union T prime prime. Right, this is the opposite of this. Okay, so here's number 20. Let's do this. What we're looking for is what is outside of this intersection. So here's the intersection. What's outside of it? This point is outside, that point is outside, that point is outside. So everything out here is outside that. In fact, maybe you can see it. It's exactly what we got up here. So I've done my best to shade that region here, is right here, which is exactly this right here. So it turns out that this set here and this set here are exactly the same thing. So this set here, S intersect T prime, is identical to this set here. And this just happens to be an example of De Morgan's laws. And De Morgan's laws says this, in this case right here, that if we take the complement of an intersection and distribute that complement, we get the complement, the union of the complements. So you can see as we distribute this complement to each one of these sets, we end up with not the intersection, but the union. And then just apply that idea up here. Let's look at this one right here. If we look at that set, let's look at this one here. If we look at this set and we use De Morgan on this, what we're going to get is S prime prime, right? And then intersect T prime prime. Right? Does that make sense? Because De Morgan says what you need to do is take this prime and distribute it to each set in there. I'm taking this prime, putting it here, right? So I get S prime prime, but then intersect, flip it over, T prime prime, right here. But what is this and what is this? Well, S prime prime is S, intersect T prime prime is T.